Hello and welcome. Have you ever seen those flexible red and blue pipes in a modern home and wondered what they are? That material is called PEX, or cross-linked polyethylene, and it's a game-changer in plumbing and other industries. Today, we are going to dive into how this incredibly useful material is made, keeping it simple and straightforward. It all begins with a common plastic you already know, polyethylene. Think of the molecules in regular polyethylene as long, separate strands of spaghetti in a bowl. They can easily slide past one another, which is why the plastic melts when heated. The key to making PEX is the cross-linking process. This is where we create chemical bridges that connect those individual spaghetti strands together, turning them into a single, interconnected 3D net. This new molecular structure makes the material much stronger, more resistant to high temperatures and chemicals, and gives it a form of thermal memory. There are three primary methods to achieve this. First is the angle method, which produces what is known as PEX-a. In this hot process, a chemical like peroxide is mixed with the polyethylene pellets before they are melted and extruded into the pipe shape. The intense heat and pressure during the extrusion process activate the peroxide, which then forges the cross-links while the pipe is being formed, resulting in a very high degree of cross-linking and excellent flexibility. The second technique is the silane method, used to make PEX-b. Here, a silane compound is added to the polyethylene before extrusion. After the pipe is formed, it is exposed to a post-extrusion curing process, usually a hot water bath or steam sauna. The moisture triggers a chemical reaction with the silane, creating the cross-links after the pipe has already been shaped. The third and final major method is the E-beam method, which creates PEX-c. This process starts with a fully formed, standard polyethylene pipe. This pipe is then passed through a beam of high-energy electrons. The radiation bombards the plastic, knocking atoms off the molecular chains and creating free radicals that allow the chains to bond directly with each other. This is considered a cold process because the cross-linking happens after the pipe has been manufactured and cooled. So, whether it's done hot during formation, with moisture after, or with radiation, the goal is the same: to transform simple plastic chains into a robust, interconnected network. And that is how you make the durable, reliable cross-linked polyethylene used all around us. Thank you so much for watching. If you found this video helpful and learned something new, please give it a thumbs up, subscribe for more content, and hit that notification bell so you never miss an update. Your support truly helps us continue to create these videos. We'll see you in the next one.